Good morning, everyone. Today we're going to do some practice question together for chapter number 5, which is confidence interval. Let me share my screen with you. All right, so these are the questions we're going to practice together. We have totally 8 questions. Okay, the first one is on page 336, question number 8. Okay. So the question number 8 is here. Okay. So we have article about application of surgical navigation to total hip as a law plus 3. Okay, a certain journal report that in a sample of 123 hip surgeries of a certain type, the average surgery time was 136.9 minutes with a standard deviation of 22.6 minutes. Okay, so part A is asking for 95% confidence interval for the mean surgery time for this procedure. Okay, so based on the question, we know this is from chapter 5 because this is confidence interval. Okay. So which equation we're going to use in chapter 5 depending on the details. For this question, it is the mean values, the mean surgery time for a procedure. Okay, so and also based on the sample size, this is 123 surgeries. So larger than 30, this is large sample, right? So based on this, we know this is a large sample. Confidence interval for population mean. All right. So because the sample size is large, so this is suitable for any type of distribution. Okay, so any distribution. Okay, so the equation actually is from your textbook, which is page 327, equation 5.1. Okay, so I'm going to write down the equation here. So this is the confidence interval is equal to the sample mean plus minus the z value, so z half alpha as sample standard deviation over n is the sample size. Okay, so in this question, the sample mean value is 136.9. Okay, so that this is 136.9. The sample standard deviation is 22.6. So this is 22.6. The sample size is 123. So 123 here. So for the z half alpha, this is based on 95% confidence interval. So we need to find out z half alpha is 0.025. Okay, so which table we're gonna use? This is table A.2, which is the z table. Okay, so based on that, table A.2, z half alpha is 1.96. Okay, so plug in the number here. We calculate the 95% confidence interval is this much. Okay. So this is the first question. Okay, this is part A. We also need to answer part C. So part C is asking a surgeon claims that the mean surgery time is between 133.9 and 139.9 minutes. Okay, so this is asking what level of confidence can this statement be made. All right, so this is back calculate. We use the same equation. Same equation here. We can use, for example, the upper bound. The upper bound is 139.9. Okay, so 139.9 is upper bound is equal to the mean value 136.9 plus z half alpha. Okay, and the remaining value will be the same. So S is 22.6. Sample size is 123. Okay, so based on this equation, we can calculate the z half alpha. So z half alpha is 1.47. 1.47. Okay. So then, we use the table 8.2. For table 8.2, remember it only tells us the left hand tail value. Okay, so left hand tail value, but the area to the right of the z value of 1.47 will be 1 minus whatever the value from we found out from 8.2, table 8.2, which is 0.9292. So which is 0.0708. Okay, so from there we get half alpha. All right, so then the confidence level, which is 1 minus alpha, is equal to 2 times half alpha, right? So this is 85.84%. Okay, so 85.84%, this is confidence level. Okay, this is part B. All right, then the next part, part D, asking approximately how many surgery must be sampled so that we have 95% confidence interval. We'll specify the mean to be within plus minus 3 minutes. Okay, so again, the same thing. For part D, this is 95% confidence interval, so the z half alpha, which is 0.025, will be 1.96. Okay, so this is plus minus 3 minutes. Okay, so this is equal to plus minus z half alpha 1.96 s 22.6. Okay, divided by square root of sample size n. Okay, so from there we get n value is around 219, okay, to the nearest integer. Okay. So this is part D of question number 8. Okay, so the next question is page 354, number 12, okay. Which is section 5.3. The reason I put these two questions together is because for question number 1 is for large sample confidence interval for population mean. And the next one is for small sample confidence interval for population mean. Okay, so let's compare these two equations together. Right. So that's the equation we use for large sample. Question number 2, let's find out page 354 first. Section 5.3, question number 12. So in this question number 12, another article called Influence of Penetration Rate on Penetrometer Resistance. Okay, so at the Journal of Geotechnical and Geoenvironmental Engineer. Okay, so that's the trivial details. The paper present measures of penetration resistance of a certain finger grain soil. Okay, 15 measurements. Okay, the sample size is 15, which is small sample. So expressed as multiple of a standard quantity has a mean value of 2.64 and standard deviation of 1.02. Okay, so look at last sentence. Find out 95% confidence interval for the mean penetration resistance for this soil. Okay, so this is confidence interval for population mean. All right, but the sample size is 15, so that's a small sample confidence interval for population mean. Okay, so small sample CI for population mean. Right. So the equation is from section 5.3. Okay. So equation number 5.9 in your textbook, page 349. Okay. So the equation is here. The confidence interval is the mean value of sample as plus minus a t-value. Okay. Because this is small sample, we're gonna use students' t distribution, so we use t-value. All right. So for t-value, we have degree of freedom, which is n-1 and half alpha. Okay. Remember, we use table 8.3. Okay. Okay. The sample mean is 2.64. Okay. Sample size n is 15, and the sample standard deviation s is 1.02. Okay, so let's figure out t-value. The degree of freedom is n-1, so n-1 is 14. 15 minus 1 is 14. So half alpha, because this is 95% confidence interval, so half alpha is 0.025. Okay, so we use, again, table 8.3 to find out this value. Okay, so let's do that together. 14, 0.025. Let me find out the table 8.3 first. Okay, so the degree of freedom is 14. 14 is here, right? And the 0.025 is alpha. Okay, we found the value for 0.025 is 2.145. 2.145. Okay, so the t-value, this one is 2.145. Okay, so from there we can calculate the confidence interval. Is 2.075 to 3.205. Okay, so this is the second question. Again, small sample confidence interval for population mean. So this is the equation. Okay, and this is where you can find the equation. Okay, so that's the second question. The third question is on page 344, question number 15, A and B. Question 15. All right. 15 here. All right. So let's read the question together. So another article, okay, so we can just skip the article. Describe a method of analyzing digital music files to determine the keys in which the music is written. Okay, so we have a sample of 335. 335 definitely is a large sample. The key was identified correctly in 293 of them. Okay, so out of 335, we have 293 identified correctly. Okay, so this is a proportion of the sample. So part A is asked for 90% confidence interval for proportion. All right, so for proportion, we only have one set of equations. That doesn't necessarily mean the sample size doesn't matter here. No matter the sample size is large or small, we only have one set of equation, okay, which is equation 5.5 on your textbook, page 340. Okay, so again, this is for any sample size n. Okay. The proportion will be between 0 and 1. Okay, so confidence interval is all right. So we have modified p value and also modified n value here. Okay, so modified n is sample size n plus 4, and modified p is x plus 2 over modified n. Okay, so that's the equation we're going to use. All right, so if the value is less than 0, we use 0. If the value is larger than 1, we use 1 because this is proportion. Proportion cannot be outside 0 to 1. Okay. All right, in this question, x is equal to 293, okay, and n is equal to 335. Okay, so the modified proportion based on this equation, so is 293 plus 2 divided by 335 plus 4. Okay, so the sample proportion, the modified proportion is this. Okay, the half alpha is easy. Okay, so this is 90% confidence interval. So this is z.05. Okay, so from table 8.2. Okay, so table 8.2. So this is 1.645. Okay, so plug in the number there into this equation. Okay, so we can get the value. The answer is so this is the answer. Okay, so this is part A. Part B is asking how many music pieces should be sampled to specify the proportion to within plus minus 0.025 with 90% confidence. Okay, so this is calculated backwards. Again, we use the same equation here, same equation. So let's define n is the sample size, right? So we want to find out the n. It said within 0.025. Okay, so 0.025 will equal to the z value 10645. Okay, because this is again 90% confidence. Okay, so z half alpha is 1.62545. And plus 4. Okay, so the modified p, the sample proportion will not change. Okay, so this not change. The only thing change is the sample size will be increased. So the sample proportion will not change, which is equal to 0.8711. Okay, so from there we plug in into this equation, we get the n value. The n value is around 486. Okay, all right. So the third question here is confidence interval for proportions. The sample size is any size. Okay. So that is question number 3. The next one is page 358. Okay, so this is the question. A group of 76 people enrolled in a weight loss program that involved adhering to a special diet to a daily exercise program. After 6 months, the mean weight loss is 25 pounds, with a sample standard deviation of 9 pounds. A second group, 43 people, went on diet but didn't exercise. And after 6 months, the mean weight loss is 14 pounds with another sample standard deviation, 7 pounds. Okay. So asking for 95% confidence interval for the mean difference between weight loss. Okay. So this is confidence interval for difference between two means. Okay. So CI for difference between two means. Okay, so we have two sets of equations for that, depending on the sample size. If the sample size is large, so large or equal to 30, okay, so we're going to use the equation 5.13 on page 357. Okay, so the equation is here. The difference between two population mean is equal to sample mean for x minus sample mean for y plus minus the z value, z half alpha, sample variance. Sigma x is population variance, standard deviation, and sigma y is standard deviation for the population y. Okay, but sometimes we do not know the population standard deviation, so we could use sample standard deviation s instead. Okay, so that's the equation. If the sample size is small, okay, we're gonna use another equation, which we're gonna discuss in the next question. Okay, so we have another set of equation. So instead of z value, we use t value. Okay, so for the degree of freedom here, we have a long equation for that, which we're gonna discuss in the next question. But for confidence interval for difference between two means, we have two equations depending on the sample size here. All right, so go back to this equation, which is question number 6. Okay, one of them, the mean value is 14. The sample standard deviation is 7 pounds. Okay, the sample size is 43. Another mean value, so diet plus exercise, average loss 25 pounds, standard deviation 9 pounds, sample size ny is 78. Okay, the z value, z half alpha, 1.96. Okay, so again, for z value, we use table 8.2. Okay, so based on this, we plug in this equation. This is a large sample. We use this equation. All right, so plug in the number, we can calculate the value. So 8.107. Right. So this is again confidence interval for difference between two means when the sample size is large. Okay, so that's question number 4. Okay, so we're gonna continue next.